bar. We're calling this a torsion bar. And you can see here it's a triangular shape and a triangular shape here. So there's nothing, you're not steering through an electric motor, you're always mechanically connected to the wheels. All it moves is this much right here. It's just about 1 millimeter each way. So what happens is, this is pinned in the top here. This piece is pinned to the torsion bar. So as you torque the handlebars, you overcome the tension on the torsion bar. As you torque the torsion bar, as it twists, that's going to move these splines, this piece here, which fits over the splines, and then as it moves up and down, as this twists, this moves up and down on those splines. The potentiometer is keyed into there. So as it moves up and down, it gets a positive and a negative voltage signal. If it moves right, it's positive, left, negative. That's how it knows which way you're turning. So as this twists, this moves this up and down. So if you don't put enough torque into the handlebars, you don't get any power assist. As soon as you start torquing the handlebar that overcomes this torsion bar, this moves, this potentiometer moves, and the electric motor moves this nylon gear, which has a really complex, really cool gear shape to it, here. This is where the electric motor helps control the steering. It's going to push or move it right or left, depending on which way you're torquing the handlebars. So, go ahead.
You said it's variable?
It's variable. The EPS ECU, which there's no pictures, there's none here, but if we can pop off the cover of one of these other ones, it's a giant ECU in that it controls the fuel injection and the EPS. So everything's programmed in as far as speed sensitive. It gives you the most power assist at lower speeds. So at 2 miles an hour, it's giving you the most. That's when you're, twisting your way through big rocks and mud and things like that. As you go faster and faster, up to maybe 30 miles an hour, it starts diminishing that power assist, so that you don't, it's more of a stability. We tried a lot of different settings, and at higher speeds, we don't want as much power assist. It's more at lower speeds. So
what if you were to hit an obstacle going 30 miles an hour? Then is it going to compensate at that point?
It still compensates. But it also reads, there's a countershaft speed sensor, or I should say a transmission speed sensor that calculates wheel speed. But yeah, anytime you try and torque this torsion bar, and it works the opposite way as well. So if I turn the handlebars and overcome the twist of the torsion bar, that's when I get power assist. And what we're talking about, feedback, kickback through the handlebars, if I hit something with this front wheel, the right front wheel, I've got the handlebars turned right. So when I hit that wheel, it's going to torque the torsion bar the other way. So the EPS is going to fight that the other way. It knows which way I'm trying to turn, and it's going to try and push it back to where I am. All this happens within milliseconds. You don't feel it or even notice it. But that's what's happening. That's how it helps with kickbacks and things like that, because it knows where you're trying to steer, and it's going to torque and fight that as you try and twist this torsion bar. Okay. One other thing is, a lot of people might, the shape of this gear is really unique. If you do hit something hard, you'd think if it was a straight gear and made out of metal, you'd definitely chip teeth and possibly break something. The unique shape of this nylon gear and the unique shape of this spiral gear, the harder you hit it, all it does is twist it harder. It never does. You can't skip a gear or things like that or chip it. It's a real durable unit. We took it through some really gnarly, nasty stuff, and we never had a problem with this system. So it's really durability proven.